Alrighty, so we are doing week 4, right? We finished week 3, which was your first dealing with classes and objects in C++ as far as this class is concerned. We did array encapsulation, which was basically you just have an array inside of a class, and because of that we also had to talk about the dynamic memory allocation, or making a dynamic array, which means you start with a pointer, and then as soon as you create a new object in the constructor, you say that that pointer is equal to a new array of some size, and the size comes from the actual parameter in the constructor. So it was just that was the basic thing. The couple of things that you needed to be comfortable with was how to insert, how to delete, and there's a picture in there where I show you basically the details of what it entails to insert and remove elements from an array. And what it meant was you have to shift a bunch of things, right? So if you're deleting a specific element, you have to shift all other elements to the right of it, one to the left. And if you're inserting an element, you have to shift all elements to the right of it, including itself, well, the place where you're going to be inserting, one to the right, right? So, and there's a couple of for loops in there so that allow you to accomplish this. And this was the main thing that we did last time. So you basically have an array buried inside of a class, and there's different things that you can do with that array. You can add to it, you can remove from it, and you can show how many things are in the array. And one thing that you're supposed to do is sort the array using the bubble sort. Somebody asked, like, I don't remember the bubble sort from 45, can you refresh my memory? And I told them that sorting is right here in week 5, right? So if you forgot how to do the sorting thing, all the different sorts are in here, and it's in the material for that week, so you can go in there and review that. Okay, if you forget your sorts. But they're coming. After this week, we're going to go back into sorting and then look at the different kinds of sorts that we can do. Okay, so what are we doing this week? It will be very similar to what we did last week. Okay, so the array encapsulation, what did it mean to encapsulate something? You allow for a coupling of actions and properties, right? So you have an age, and you have a way for you to change the age, and you have a way for you to look at the age, right? Age variable. That was one thing about encapsulation, and the other one is hiding the details inside of the class itself, right? So what are you hiding? You're hiding the array. So this week we're kind of continuing with that same idea. All right, so let's go over. No, that's not it. Encapsulate, chapter, object. These are just different. Yeah, encapsulation, right? So the different meanings of encapsulation. And again, encapsulation means restriction of access to your variables, and that's the reason why we make these things private. Okay, and it's the same thing that exists in Java also. There's a private, there's a public. Okay. In fact, I was just answering somebody what's the difference between private and public in Java. Okay, so bottom line is private things cannot be accessed by anything outside of the class itself, and public things can be accessed from other files that are outside of the class, outside of the program file. Okay, so in order for the outside world not to mess with your data and accidentally go in there and type up nonsense inside the properties, what you want to do is you want to provide public methods, make the variables private. That way, the only way you can change the properties is through these actions or methods or functions or modules or procedures, right? So if you hear module, procedure, function, it's pretty much the same thing. Okay? So going back to week 4, which is the current week, we're going to talk about the abstract data type bag, and its computer science implementation, which is the data structure. Okay. One way to implement a bag, and first of all, what is a bag? It's a collection of items, right? Just like you had, well, you haven't had that yet, but basically it's a collection of different objects, right? We're going to make an array of objects, and we can put these objects in the bag. The simplest thing is you just have an unordered array. That will be an example of a bag, right? You can add things to the array, you can remove things from the array, and you can have arrays of objects. You don't have to have just arrays of integers, you don't have to have arrays of characters, you can have arrays of different types that we define. Okay, so let's have a look at chapter 3 from the Karana book, which is actually a Java textbook. Okay, but whatever, we're gonna use it, I think. Download it. Okay, so array-based implementation, and just like a lot of things in this class, we're going to start with how you do this using an array, and then we're going to use different ways to implement the same abstract data type. Okay, so again, what is an abstract data type? It is really just a real-world problem, and basically you're focused on how things are going to work and not how you're going to implement them. Okay, the actual implementation of an abstract data type is the data structure, which is what we do in computer science. You can implement something. You can implement an abstract data type with an array. You can implement an abstract data type with a linked list, and so on and so on. So there's different ways to implement a solution in computer science, and those implementations are called data structures. Okay, and the basic things for a bag are very similar to what we had to do. You're going to have to add to the bag, you're going to have to remove to the bag, and fixed size arrays. So I kind of went over this last time. So you have your static arrays, which is an array that you create without using a pointer, and you have your dynamic array, which we can give it a size in the constructor once the program is running. So the fixed size arrays, static arrays basically are created before you run the program. Dynamic arrays are created as your program is running. Okay, arrays are fixed in size, which means you cannot expand them or cannot shrink them. They're very convenient if you want to access a specific element. So you can have an array of million items, and you want to go to like number 999, you can go straight to that index and access it directly. So that makes them convenient for those kinds of things. And there's some examples here of creating an array of objects. Okay, so item type is basically like character or whatever. It's basically a class that you define called item type, right? And we're going to make an array of objects basically. So that's something that we can do. And these are the default core methods in the array or in the bag. So in C++ and in Java, there's these things called templates, and that's what these things here are basically. What a template is, it's a way for you to create like a template for any kind of a data. So you want to have a class that not only works with integers, but also characters, but also doubles, and also floats, and also whatever. That will be a template. Okay, and I'm not going to get into this right now, maybe later, but that's what this is. Basically, the generic bag which exists in the language, in the C++ language, allows you to create a bag of whatever you want. Okay, but for simplicity's sake, we're going to make bags of specific things. Okay, and what are the things that you're supposed to do to the bags? Well, you're supposed to count how many things are in the bags. You're supposed to be able to add new things to the bag, right? Adding to the bag, looking at how many things are in the bag, and what else is there? figuring out how many, well, I guess that's the same thing. So you might want to show all the things in the bag. You might also want to show how many things are in the bag. You might also want to check to see how many things are, I mean, if it is empty, you can also look for a specific element or a specific item in the bag. Okay, so those are the core methods or the core things that we need to be able to do with the bag. Also, they're adding a get frequency of, so how many times does a specific grocery item exists in your bag, right? How many lemons you got or whatever. And right, this is the contains, if a specific item exists in your bag. So these are the different methods that we're going to have to build. Unlike what a lot of computer science classes do, what they do is they kind of show you, okay, this is how the bag is supposed to work, and now just make a bag using the generic thing that exists in the language. In this class, my class, you're going to have to write the thing. Okay, so you're going to have to create the bag. And that's that. Get index of. Okay, moving along. Okay, so that's basically the bag with not too many details. And let's have a look at this thing here that I have. Okay, so this here is an example of a bag. All right, so I wrote it. So first of all, what are we going to do? We're going to create a class called item, right? And inside that class, we're going to have two different variables or properties. They're private because we don't want the outside world to mess with them unless they're using my predefined methods. Okay, so I have two different variables. One is name, one is cost, right? You're going to have some kind of a product like apples, and you're going to have a cost for that product, whatever that thing costs. Okay, and we're going to use two different classes. Both of them are going to be inside of the same file, because remember, I don't want you to like split things into separate files and then have headers and this and that. We're just going to keep it simple as possible, so we can get the concepts that we're trying to get through. So yeah, everything is in the same file, in which we have a main.cpp, which is, again, in C-line. I wrote the whole thing. So going back, I have two variables, and this time what I'm choosing to do is I'm not doing what I did in the previous one. So let me go back to the previous week so you can see the array encapsulation thing with it. This one. No. Well, yeah, I guess you can look at this one. So in this particular one and the earlier one, the examples that I did was basically you state what the method or constructor name is going to be here, like so, and then you go and you define them underneath, right? So that's one way to do it. Another way to do it is basically just grabbing this piece and putting it where this is. And that's what I'm doing. Okay, so basically instead of saying, oh, there's going to be a constructor called item here, and then I'm going to define it down there using, a million dots and some extra typing, right? I'm saving all this by putting the whole thing in here. Okay, so first of all, what do we call this? What kind of a method is this? Starts with a C. Constructor. Okay, good. So why is this a constructor? Same name as the class name. Excellent, right? So my class is called item. There's some kind of a method here that doesn't say void, or it does not have a return type, and it's just item with parentheses. So this constructor is used whenever we're going to make a new object called item. Okay, so the default object that we're going to create of the item type is not going to have a name, and it's going to have a cost of 0, right?
And you said it's 0 because if not, it'd be garbage.
It would be garbage, yeah, because this is C++.
Okay.
Right? If this was Java,
It would just say it's 0.
it will make it a 0. It will make your strings equal to null, so you don't even have to worry about making a default constructor. Okay, so this is my default constructor, and let's see if I am using it anywhere. No, I'm not. Right? So this is my default constructor. I'm having one just because I want to have one. And then underneath it, I have my explicit constructor. How is this an explicit constructor? Well, it's basically also a constructor. It's got the same name as my class. and it also allows me to enter a new name and a new cost and set my name and cost equal to these, right? And I'm actually using that right here. So let's say I'm saying we're going to have an item. That item is going to be called an item, and the item is going to be a Fiji apple, and we're going to have that thing cost $4.99. Okay? So as soon as I say Fuji apple here and then $4.99, those two values, Fuji apple goes into new name, $4.99 goes into new cost, my name becomes equal to the new name, my cost becomes equal to the new cost, and now I have created a new object. Okay? The Fuji apple, the $4.99. Okay? So that's one. And of course, I need some methods to show the properties, right? I want to be able to show the thing. Let me zoom out a little. All right, so I want to be able to show the name and the cost. And I also might want to get the name, which returns the name, or get the cost, which returns the cost. And maybe once I have created the item, maybe I want to change the Fuji apples to lowercase f and $3.99. Then that's what this method is for, so that I can modify the existing object. Okay. Set item allows me to get one item, create an item, and then once I have created another item, I'm going to send one item inside of another item. Okay? And this is similar to, if you've done Java, similar to that, exercise 3.4, where you have swapping properties of different objects. Okay? And hopefully I have some examples in there so you can see it. But the bottom line is, what we're going to do is, you're going to have one item, and you're going to use this set item method to to exchange properties of two different items, right? So you're going to exchange their names. You're going to exchange their. Well, actually, no. This item is going to become equal to another item. Okay, so that's that. And the reason for this is because unless we overload operators, which is something we could do. Let's say you want to have, you have created an apple. I mean, an item called apple, right? And then later on you make another item called apple, and you want to make the first apple equal to the second apple. Maybe the second apple has different price or whatever. You can't just say apple 1 equals apple 2, right? Because the equal operator is only works with, like, if you want to make integer equal to an integer, or if you want to make a float equal to float, or a character equal to, yeah, or a string equal, you can do strings too. So you can make one string equal to another string, right? You could do these things with, the basic data types. But let's say I make an apple and I tell it, make this apple equal to another apple. It'll be like, wait, what part of the apple am I making equal to? So the Java way, the way you would do it in Java is you would do just, you don't even have overloading operators in Java. Okay, you cannot go in Java and tell it, okay, the meaning for an equal when we're adding an apple is going to be we're adding their costs or something like that. We can't do that in Java, but you could do it this way, right here. You basically just create a method, and you're telling, okay, well, this name here for this object, which is using the method, is going to be equal to another item's name, and the cost for this item is going to be equal to another item's cost. Okay? And hopefully I can give you an example for that too. All right, so the basic thing is, just as usual, write a basic, just the basic things like a constructor, and then see if it works. So I test it, I see if it works, that part is good. Okay? I'm not going to go and test all these other ones yet, okay? Maybe later in this example. So for now, I know that I can create an item, and that's good enough. Okay, now, here's how we're going to make a bag. Okay, so this is my class bag. In that class bag, I'm going to create a dynamic array. So the array is going to be created as my program is running using, and it will be an array of items, right? So just like I could say int asterisk an array, I could say item asterisk an array, and I can make an array of items, just like I did with the other one, right? So that's what we're doing, and that's basically the bag. Okay, you're going to have number of items, which is how many things you have added into this thing. You're going to have max, which is how many things can the bag take, And we're going to have a way to insert into my bag, right? So what is the insert going to do? Well, it's basically we're going to insert a new name and a new cost, and that's what the set item is for, right? So items is basically, think of it as a single item, right? So this is, let's say we're adding the first item. Number of items is equal to 0 initially, right? So items 0, which is the first thing in the bag, dot set items name cost. That allows me to use this right here, set item, right? So I'm just making a new item, setting the properties of that item, and then I'm increasing the number of items. So my number of items is now 1, okay? And the number of items is really just the index of your item, okay? Number of items is 0 initially, which is the index of the first one. Now, as soon as I added the 1 already, number of items is equal to 1 now, which is the index of the second one, which is where I'm supposed to insert the next one, okay? And one thing I could do here for the insert item is to check to see if my number of items is less than my max, minus 1, right? So if I have an array of 3 things, I can insert at index 0, 1, 2. I should not be trying to insert at index 3. So it would make sense for me to throw an if in there and say, well, if my number of items is less than max minus 1. Sure? But just for simplicity's sake, that's not here. Okay? Just to give you the simplest possible example. So we're just adding items. We're assuming there's enough space to be added, and we're not handling anything else. Okay, so we're going to look at that. Then also there's a insert item into the bag. So I can insert a pair of a name and a cost into the bag, or I can make an object like I did earlier here. So if I have already created an item called an item, right? Maybe I should have called it an apple, right? If I have already created an item and I just want to add that object into the bag, I could do that too. And how am I going to do that? I'm going to use the insert item method, and that thing is going to work the same way as the other one, right? But instead of set item with underscore, I'm calling it set item with capital I, and this time we're sending the item itself. Okay, so let's go back to this one. So look at the set item. This takes an item object, right? So my current item, which is, let's say, index 1, is now going to be equal to the name of the item that I'm trying to add, which is maybe this one, this unitem. So let's say I'm trying to add this unitem. Okay, so this is the unitem. So unitem get name. So I'm getting the Fuji apple, and then cost is equal to unitem dot get cost, which is the $4.99. So it's a way for you to send one object into another object and make one equal to the other one. Okay. And then you want to look at the size of the bag, which is just basically the max, int max, which is how many things you have in the bag. You might want to show the different items, right? So I have void show items, and inside that void show items, I have a for loop that goes through as many things as I have in the bag, which is the number of items. And I say items.show. What is my items.show? Well, that is this one. Okay? So you have one class's method calling another class's method to do something else. Okay? So we're kind of abstracting ourselves from the actual, inner class. So the inner class is the item, then the more outer class is the bag. Okay?
So you can add so that would be a Fuji apple, and then the bottom part you can add, so you add a banana or something, right?
Yeah.
Is that what you're saying? And then you can set the cost. That's just returning those.
Yes. So then this thing shows you those properties of the different items. Okay. And of course I have a delete first because that's the hardest one, right? So deleting the first one requires you to shift all the other ones to the left. This is basically the shift right here. Items I is equal to items I plus 1. You're going from 0 to max minus 1, right? So we're shifting all the elements.
Would that be by size or by cost? Is that what you're doing? If you want to.
Which one? The delete first?
Well, if you want to resize the bag or shift the elements one to the left, you do it.
I'm shifting all the entire elements because I have an array of items.
Oh, okay.
The item itself contains a name and a cost, but I'm not making separate arrays for arrays and separate arrays of costs. I'm making one array that is of items. So I'm actually, it works the same way as you would if you were shifting. Remember that's why we did that insert and delete with an integer array. Same thing. It's the same kind of shift. If you're deleting the first one, you got to shift all the other ones one to the left. You're not shifting integers. You're shifting an array of items. Okay. So that's what this is. And this is to shift all elements one to the left. That's why it's from I 0 to I is less than max minus 1. In retrospect, I think it would make more sense to shift, make this loop not go until max, but go until number of items. That way you actually shift the things that are, existing, not the whole thing, even though, the things that you haven't added. So you may have an array of size 100, but you only added 3 things to it. There's no point of you to shift all 100 things when you only really need to shift the 2 things. If you delete. Huh?
That would be number of items.
Yeah, we'll just replace max minus 1 with number of items minus 1. But since we're saying shift all elements one to the left, I guess I kind of covered myself. So, all right, and the contains is pretty straightforward. You have a loop that goes through all the items that you have currently added, and if you're looking for a specific name, which is a string, and if the string name to find happens to match items square brackets I get name, then this method returns true, otherwise returns false. So again, items get name. Where's the get name? It is this right here. Right? And that's why I'm saying that, whenever you have some kind of a class with some kind of variables, at the very least, you're going to need some constructors. You're going to need a way to show the properties of the thing. You're going to need a way to return the properties of the thing. And you need a way or a couple ways to change the properties of the thing after you have created it. That's like in everything, right? In Java, they call these accessor methods and mutator methods. So the accessor one allows you to see it, the mutator allows you to change it. So if that helps you remember it, right? So these are the basics. Whenever you make a class with some variable, you need to have a way to initialize it, you need to have a way to show it, you need to have a way to usually return it, and to change it. So that's what we do, and that's what we're using. Okay, so we're using the show, we're using the get, okay? And then what I'm doing is I'm even going a little bit crazier now because when we're talking about a bag, we really don't need to have it sorted, but what the hell, why not, right? So I'm gonna have a sorted bag, sort by cost ascending, and what is this thing doing? It's using the bubble sort that you had to do previous week, hopefully you remember. Right, and all we're doing is, so this is your bubble sort, and you're checking if the item on the left is bigger than the item on the right, and then you're swapping them. How we're going to swap them? I could have put the swap inside of the if, but it just makes it cleaner to put it into a separate method. So this method swaps items based on their indexes. So swap the left one with the right one. So all this thing takes is an index, okay, and I'm creating a new item called temp. Temp is equal to the first index, right? The item with the first index. Then the item with the first index is equal to the item with the second index, and the item with the second index is equal to the temp, right? So same thing that we've been doing, but now we're a little bit more, question?
Well, I was just looking at since you had an array, and the array contains the item and the cost, I was just looking at if items j dot get cost is greater than items j plus 1, swap them.
Yeah.
It knows of the get dot get cost, but what are the items? To take the item with the get cost. So it takes the entire line, or
No, the get.
The line contains the array, item, and the cost.
Well, let's look at what get cost does. So go back up. Get cost just returns the cost.
Right. But it's not just the cost in that array. It's the cost plus the item.
But I'm not returning both. If I had a method called double get return name and cost, then it would be getting both of them. But since I defined a method called get cost, it only returns the cost.
I'm a little confused because I thought maybe we just swapped the cost in those two array names.
No,
not the entire array.
we're looking at the cost we're looking at each of the individual items' cost,
Right.
and we're sorting them based on cost. But so it's like, let's say you have first element is apple and it costs $4.99, and second element is sausage and it costs $6.99.
Right.
So apple is cheaper. Well, let's make it apple. Meat is first and the apple is second, right? So apple is on the right, meat is on the left. We want to swap them. We're not swapping just the cost. We're not making meat equal to whatever the apple was and the apple equal to whatever the meat is. No, we're just getting the apple and shifting it to the left of the meat.
Right, but since the focus is only on the cost, it knows to take the entire
Yeah, well, the swap is
array elements.
the way I'm telling it to get the entire thing is in the swap. So remember, I have an array of items.
Also, the index is referring to the
To
item one. and
Item
cost
one, yes. So I'm shifting items. So I have an items array. Good question, right? And then from that array, I mean, I can deal with that array as I did with an integer array, right? So I'm just swapping the left and the right, and then the array of items, each item has a cost and a name. Yeah. Any other questions? Yes, sir.
Is there a reason like you had to make an item temp? And you just used like a variable to swap it?
Well, that is the variable. Temp is the name of my temporary variable, which is going to store one of the items so that I can swap their values.
Wouldn't you need a float or a double?
Well, no, because the items is an item array.
I'm sorry, I was looking at I was thinking of the cost.
For the cost?
Yeah, because the cost is usually like $4.99.
Sure.
It's not an integer.
We don't. Well, the indexes are the integers. Well, yeah. Get cost does return a double, right? If you go back up here, see get cost. What does it return? It returns a double, right? The only things that are integers in this are just the indexes, right? My indexes are just, those are the only ones. Okay. Any other questions? That's basically what data structures are, right? These kind of things we're going to be doing, those are data structures. Okay? And I know there's a lot more complicated ways to say this, but I'm trying to keep it simple. Okay, so and there's some more explanations in there about these different things that I just explained to you, right? And then all this stuff that does the shifting, right? Some other pictures in there that I threw. Okay, so that's basically it. So most expensive, show reverse, get frequency. Okay, so you got this? Any questions on any of this stuff? So what do you have to do? For you got to go in there, and first thing you're going to do is you're going to type up the item class. Okay? Then again, go and check, make a main, check to see if it works. If it works, you're good to go. Then go and make a bag class. Write up all these different methods. Then as soon as you're done with this thing, maybe I should have provided the main in there. Damn it. Why didn't I do it? I didn't put a main. Well, what you should do is create a main. I should have put the main in there. But basically create a main and where you're going to be checking all these different methods that are part of the bag class. Okay? So just like I did for this main here, where's the main? Which is the same main basically. So all right, I have an item. Later on, I'm going to make a bag, right? So instead of item, I'm going to say bag, a bag. Now what's in the bag constructor? What value am I going to put? How many things are going to be in the bag, right? And then as soon as I figure out how many things are going to be in the bag, that's how many items. That's going to determine the size of my arrays of items. And then I'm going to use my bag to insert things, my bag object, right? So just like I had item, an item, I'm going to have a bag, and I'm going to add things to the bag, just like and then I'm going to show what's in the bag, and so on and so on. Make sense? Okay? And if it doesn't, you'll find out soon. Yeah, these are the explanations. I really should have provided the main. I'm going to go and edit this a little bit later. Okay. So, what do you have to do? You get it. First of all, you got to get this stuff to work, right? So test all these different methods. Test your show items. test your delete first, test your contains, test the sort by ascending. The swap can be pretty much tested by the sorting thing. Of course you want to insert items, okay? Insert an item, giving it a name and a cost. Insert an item by inserting this other one that you have created, okay? And then when that whole thing is created, then we're going to use some other things. So this is what you have to do. You have to create a most expensive method, right? Which goes through the bag, looks for the most expensive item, and it shows you. Okay, you have to do show reverse. So in whatever order you insert the items, show reverse will show it in reverse order. Okay, get frequency. Remember that was one of those things that we talked about when we were looking at the PowerPoint. So you want to see how many apples are in your bag, right? So you're going to use the get frequency to figure out the items. Okay, how many times a specific item appears inside of the bag. And we're talking about the name. Okay, the only thing you're gonna look at is the name. So you could have an apple that's $4.99, and you can have another apple which is $5.99. As long as it's called apple, case sensitive, uppercase A, PPLE, then you count it. Okay, you don't care about the cost. So you could have a different cost, but as long as it's the same name, you count it. Okay, bool delete item. This is similar to the delete, that I have a delete in there. So here's your delete first. Delete first starts the I at 0, right? Why is it start at 0? Because you're going to shift everything to the left on top of the 0, right? So let's say this is your 0, you're deleting the 0, you're going to move the 100 on top of the 0, then you're going to move the next thing to the right of the 100 on top of the 100, then you're going to move the next one to the right of that, one to the left, right? Now, what you have to do is, for the delete one, you're not going to be shifting everything on top of the 0. You have to find which one you're going to be deleting. So if I want to delete the 5, so let's say this is my index 0, index 1, index 2, index 3, right? So the 5 is index 0, 1, 2, 3, right? So 5 is index 3, so that means that now my delete will have to start at 3. Okay, so you're going to have to modify the delete first a little bit so that it first finds where the item is, and then if it finds it, then it shifts everything on top of that one.
Since it's a bool delete, doesn't it have to first check to see if the item exists?
Yeah. I guess I forgot that part too. Yeah, just to keep it simple, I guess I'm assuming, well, which one, the delete or delete first?
Well, it said down there, I was looking at your main where it said
All right.
bool delete. So to me, it's going
Yeah,
to
yeah,
be
yeah, yeah.
true. So if it's not true, it's not
Correct. So if it can do it, if it can find the item, it returns true. And if it doesn't, it returns false. So it'll be very similar. You can actually use your contains. So you could, if you really are learning the material, you should be using the methods that already exist. I'm not going to go look for the item. I'm just going to look I'm going to use the contains, maybe, right? And only if it contains the thing, then I'm going to look for it. But you can put this stuff inside of the delete also, right? So similar to how the contains returns true or false, that's how the delete item is going to return true or false. Okay. Get index of. Find the index of where the apple is. Okay. And by index, which index am I talking to? I'm talking about the index that we used for my array of items. So so I have an items, right? Items, square brackets, number of items, whatever. So the index is, we're talking about the index of this array of the items. Okay? So that's that. And sum all. So you're going to go through all the items in the bag. You're going to sum them up, and you're going to give me the cost, total cost, how much you paid for everything in the bag. Okay? That's it. Any questions? Let me go back to the week 4. See, maybe I put some more information in there, but probably not. No, that's it. Okay? So yeah, the only thing that I should be adding, the only thing I need to be adding is, I need to show you the main maybe, before I tested it, but yeah. Any questions? Comments? Concerns? Okay, so that's all there is for today.
Email me if you have questions.
Email me if you have questions. You know the drill.
I'm looking at it like
Yeah, yeah. I did it quicker today than most days.
I have a question about C-line. Like, so when you make things in like code blocks, you can send it to like a specific folder.
Yeah.
How do you do that on C-line?
C-line.
Every time I try to like send it to a folder, it like jacks it.
Okay.
It does it directly to the file paths, like that's how it runs it.
Okay, so are you asking where does it save the CPP
No,
files,
no,
or how do you move this file to somewhere
It
else?
saves it on like the whole drive. I want to put it all in a folder so I can have like a folder.
Oh, he wants it in one specific.
Yeah.
folder.
That, yeah, so the question is, how do you make C-line, so you basically want to list all the files in here, that kind of stuff?
Yeah, kind of.
Okay.
I know the problem is that it will try to run two mains and it'll
Correct,
figure out
yes.
exactly what happened.
So yeah, what I would recommend is use C-line to just create the files and, well, not create, but basically just write your code in C-line, and then when you're done, right, just grab the whole thing and save it. So let's say this is my P2, right? Whatever, some assignment. I go in there, I get this thing, I go to Sublime, right? Paste that thing in there, and then save it with wherever you want. That's the easiest thing to do. If you don't want to do that, then you have to go and you have to edit the CMake list to tell it which one to compile. I think it's easier if you just paste it in an editor, save the file with whatever file name you need in wherever place you want, and then if at any point you want to go and edit that file, then open the file from the editor, get all the stuff from it, copy it, and then go to your main in the C line and then paste it in there. That's just make your life easier. Otherwise, you have to edit the CMake list, and you have to basically change this thing here to tell it which particular file it needs to compile. Yeah.
Yeah, it was like, it won't, like all the debugging, all like the features on here wouldn't work because of
No.
strangeness of the
Yeah,
file.
yeah. If you have multiple files with multiple so basically this project can only be started from the file which has the main, and you can only have one main in per project. And since that's not what we're doing, right? Every file we're doing, unless you want to create a separate project for every file, I would just say just write everything in the main CPP and then copy paste it in an editor and save it. Okay? Other questions?
Tomorrow in LS 106, that's what we're gonna be.
For the club, we're trying to figure out the room still, because the person who's responsible for saying yes, okay, this room can be used, she hasn't answered her emails in a couple of days. But if there's no changes, I think we're going to be in LS 106 from 1 to 2. We changed the club meetings from 1 to 2 because not everyone could make it. And if you want extra credit, join the club. All right. If you want something good on your resume, join the club. If you want free pizza, join the club.
LS is in the library?
LS is the life science building. So if you start going the walkway towards the other side, right? It's like the last building on the left. And when in doubt, Gavilan campus map will be your guide. All right. So where's the LS? It's this building right here. So we're in the BU, so you go out, make a right, go all the way down, and right before you get on that bridge, the building to the left is the LS, and the entrance for the 106 is on this side right here. Okay, so yeah, and that's for now. Hopefully we can stay with that room. Before we used to be in the BU building, which made my life easier, but whatever, we can all use the walk.
Can you put
Okay.
that on applications to transfer?
What, that you were in the club?
Yeah.
Shall we? Yeah, it'll be something that definitely will help your transfer.
Yeah,
Yeah, it's better than nothing.
that's true.
Plus, there's also, the club goes to competitions and stuff like that.
Yeah.
If you just Google computer science club, you're gonna find out we're on top of we're on top of San Jose, we're on top of Davis, right? So I guess we're doing something right.
That
So
has nothing to do with probably not time to search.
If you search it within our area, it will show up as on top of the list. But if you go to like someplace else, it won't be on top of the list. All right. But within this area, within the Santa Clara, I think too. All right. And by the way, we can find out. Watch. Let's try it. In fact, let me just turn this off. Stop recording.